All right, so we are starting chapter 9, and chapter 9 is about sequences and series. We're going to just start with sequences, and these are all the same kind of question. They're saying, write the first 6 terms of the sequence. I would encourage you to see what you know on your own first, and then turn on this video for like clarification and kind of follow how I do it. You could pause it and then you could unpause it when you've tried the first question and then move on from there. All right, so write the first 6 terms of the sequence. When we talk about terms, we're talking about what is inputted into the equation. So the term number is the input. And that is represented by n. And then we will have the value at that term number. The value at that term number is the output, which is represented by a sub n. And we've done this so many times. Term number and value at that given term would be like finding an x value and finding a y value, where you put the x in and then you find the answer for y. And then usually we graph it. So we're going to do the first 6 terms. So I'm going to start with A. I'm going to zoom in here a little bit. Start with A, and then I'm going to say sub 1 equals 2. So when I make n equal 1, every place that I see an n, I'm going to make that equal 1 minus 4. So do a sub 1 equals 2 times 1 minus 4. And I am just going to set all of these up really quickly because it's hard for me to talk and think and write all at the same time. That's a lot of work. So then I'm going to do the second term, the third term, the fourth term, the fifth term, and the sixth term. So I'm going to plug in 2, 3, 4, 5, 6. So you can see that the only thing that's changing each of these in each of these equations is the term number. And so these are easy enough. We could do these by hand. 2 minus 4, negative 2. 4 minus 4 is 0. 6 minus 4, 2. 8 minus 4, 4. 10 minus 4, 6. And 12 minus 4, 8. And you'll probably notice a pattern as I'm writing these down. We're just going up by 2s. It's a bunch of even numbers. If I were to plot these, my x-axis would be n, and my y-axis would be a sub n. And so I would go to 1 on the x-axis and negative 2 on the y, or on the n and the a sub n. And then I would find 2, 0. Let me write down these ordered pairs. So this would be like the ordered pair 1, negative 2. I'm just going to do these in black. 2, 0, 3, 2, 4, 4, oops, 5, 6, and 6, 8. You could actually say, you know, for every, or the output is going up by 2, going up by 2 every time the input goes up by 1. And that's a slope, the slope of 2 over 1. And because it has a slope, this is linear. Each of these goes up by 2 every single time. It's a constant amount. So that makes this linear. Now, I'm not going to connect the dots. When we do sequences, we only use the positive integers as our input. We only use the positive integers as the input. So I'm going to say my n values are 1, 2, 3, 4, dot, dot, dot. And it just goes on from there. So I'm not inputting 1.1 or 1.5. I'm not inputting the numbers in between there. So I don't actually connect these. It's linear, but it isn't a line. It's only those specific ordered pairs. All right. If you watch this, try the next one on your own if you haven't done so yet. Pause the video. Okay, by the magic of video, this got done. After you have all your values, all your A sub 1s, we're going to talk about what kind of picture this makes. I hope that you can look at the equation right now and say, squared, this is going to be quadratic. And quadratic makes a parabola, a U shape. This negative right here is going to mean a reflection, and the 6 is going to mean it's going to be up 6. So it looks something like this. Except it's not going to be connected, so it's just going to be points. I want to show you something that possibly you did in Algebra 2, and that is to look at the pattern as we are inputting 1, 2, 3, 4, 5, 6. What is the pattern from output to output to output? So the pattern from input to input, these are just +1s each time. So these are all constant. But what's happening over here? Let's see, we have a -3, we have a -5, -7, -9, and then -11. So it's like we're subtracting 2 more than we subtracted before. If I take that and I take what I just said and I just kind of write it as a second pattern, I'm going to be subtracting 2, subtracting 2, subtracting 2, subtracting 2. So where linear was constant the very first time with its outputs, quadratic is constant on the second time that I find the pattern for the outputs. This thing that I'm doing right now, finding that pattern for the outputs, this is called finding the finite differences. And once they are constant, once we have a constant finite difference, the number of times that we had to take these finite differences before it became constant tells us that we have a polynomial with a degree of 2, which is a quadratic. So just having to take them once would be linear. Taking them twice would be quadratic. If you had to do it 3 times, that would be cubic. Okay, the rest of these, well, not every single one, but the next few you should be working out on your own. what I want to talk about and make sure that you understand, something that we would talk about in person would be, what kind of equation is this one? And we did this somewhat recently where the variable is in the exponent. This is going to be called exponential. But there's something very interesting about this exponential that we did not do when we were covering it a couple chapters ago, or was that last chapter? I'm just going to fill out part of the okay, so if I have negative 2 to the 1 minus 1, that's negative 2 to the 0, and that is 1. If I have negative 2 to the first power, that's negative 2. If I have negative 2 to the second power, that's 4. Negative 2 to the third power is negative 8. And then just following that pattern, I'm going to have 16 and then negative 32. So when I look at these ordered pairs, especially if we look at them on a graph, we're going to have 1, 1. Then we're going to have 2, negative 2. Then we're going to have 3, 4. And then we're going to have 4, negative 8. So these do not connect. They do not connect. But if I was trying to connect them, they'd be crazy. They're just going to get bigger and bigger, and they're going to alternate signs. If we ever raise a negative number to consecutive powers, like the term number, we will get alternating negative signs. The sequence will have alternating negative signs. And you can see that positive, negative, positive, negative, positive, negative. The next one is rational. Go ahead and pause the video. Make sure you do this one first before I go over it. Okay, so I went ahead and I filled out the first 6 terms of the sequence, and some of them I had to reduce because they're fractions, and sometimes fractions reduce. What I want to call your attention to is the majority of this chapter is not finding the first 6 terms. The majority of this chapter is not this introductory lesson. The majority of this chapter is not what we're doing today. This is to give you hints and tips and ideas so that what is going to happen is you're going to go backwards. You're going to be given the answer, and you have to find what pattern gave you that answer. So what I did over here is I wrote both sets of answers, and one of them is the just not reduced. This one is not reduced. But the red one is probably more like something that you would be given, where it's reduced already. So I wanted you to practice this so that you can see that when it's reduced, you know, I'm looking, how do I go from 2/3 to 8/7 to 3? I'm looking for a pattern there, and then all of a sudden I have a 2 here. I'm looking for a pattern. On the top one, when I'm looking for a pattern from 4/6, 8/7 12 eighths, 16 ninths, I actually noticed that 4 to 8 is plus 4, 8 to 12 is plus 4, 12 to 16 is plus 4, 16 to 20 is plus 4, 20 to 24 is plus 4. And then on the bottom, I noticed plus 1, plus 1, plus 1, plus 1, plus 1. So the not reduced form is just like so much easier to find the patterns, but you're going to be given the reduced form. So we really need to start thinking about how can I make the pattern above? How can I make this black pattern by using the red numbers? You want to look for any potential pattern. So just, I mean, I already know the answer, but just looking at this, I might notice 8, 16, 24 are all multiples of 8. So then I might say, how do I make this number fit into there? And how do I make this number fit into there? So what's exactly in the middle of 8 and 16? Well, that would be 12. And that's 4 away. So if I make the top 12, then I have to make the bottom 8. And as soon as I make the bottom 8, now I've got 7, 8, 9. So we start kind of figuring out clues of how to unreduce them without knowing what the original fractions were. I have another example like that on the other set of notes. All right, number 5 is quadratic. All right, so number 5, you will notice after I filled out the first 6 terms that each of these answers is a perfect square. 7 squared, 6 squared, 5 squared, or actually it's negative 7 squared, negative 6 squared, negative 5 squared. So when I'm looking at 49, if I'm only looking at the 6 terms and I don't know what the original question was, let's say I'm trying to go backwards and find the original question, I don't know if I squared 7 or negative 7 to get 49. So that's something that you have to kind of figure out and play around with. I don't know what I squared to get 4, but it could be positive or negative 2. The input number, 1 itself, doesn't just give me 49. 2 itself doesn't just give me 36. You kind of have to manipulate and figure out how we can change 1 into a 7 that squares to be 49. How can we change 2 into 6 that squares to equal 36? Just from the pattern right here, I would be able to tell that that is quadratic for sure. So I would know I'm looking for n squared or some sort of n squared. And then if you did not recognize that and you wanted to look at differences, oops, that's not plus. That would be take away, what is it, 13, take away 11, take away 9, take away 7, take away 5. And then the second set of differences, take away 2, take away 2, take away 2, take away 2, is going to tell you first finite difference, second finite difference. So that's why I know that it's quadratic. I mean, that's one way I can tell that it's quadratic if I couldn't look at the numbers and figure it out. All right, now we get to ones that are a little bit different. This is not giving me a formula where I can just plug in the term number. This is telling me the first term is 7. All right, so I already know a sub 1. Sorry, I said 7, negative 7. So now I have to find a sub 2. But all I have is this equation. So wherever I see an n, I'm going to plug in 2. So I will have a sub 2 minus 1 minus 8. I'm going to simplify that a little bit, and I get a sub 1 minus 8. Well, I already know what a sub 1 is. It's negative 7. So I substitute a sub 1 for negative 7, and I get negative 7 minus 8, which is negative 15. So now I'm going to do a sub 3. To find a sub 3, I'm going to plug in 3, so I get a sub 3 minus 1. And that's going to give me a sub 2 minus 8. Well, they gave me a sub 1, but on my last line, I found a sub 2 is negative 15. So now I'm going to do negative 15 take away 8. So now I'm going to plug in 4. A sub 4 is equal to a sub 4 minus 1, take away 8. So a sub 4 minus 1 is a sub 3, take away 8. I just found a sub 3, it's negative 23. Oops. Take away 8 is negative 31. So this formula, we're going to learn more about what this kind of formula is. But this formula, you have to know the previous term. You have to know what the previous output was. You know what the previous value was to be able to find the next value. You rely on the previous value to find the next value. So if it's set up this way, you just got to start plugging in 1, 2, 3 and substitute what you already know. Now here's one that doesn't have A's in it at all. So this one, we need to understand, and I wrote this earlier, a sub, well, let me start with n, is like the x, where it's the input to the equation. A sub n is like the y, which is the output. Well, we've studied functions, and f of x is a function at a value of x. So f of x is just a y after you plug in a specific x. So f of x is an output when x is the input. So this right here is kind of what they've set up for us, except for they don't have f of x, they have f of n. So f of n would be the exact same thing as like an f of x would be. We're just using a different input letter. So this is telling me f of 0, when I input 0, I get negative 5. I need to input the terms 1 through 6. So I'm going to do f of 1. And that's going to be equal to 1/5 multiplied by f of 1 minus 1. So n right here is 1. I'm going to plug it in all the way. So f of 1 means what is the value when we plug in 1? So that's going to equal to 1/5 multiplied by f of 0. And we already know what f of 0 is defined as. That's negative 5. So now I'm going to have 1/5 multiplied by negative 5, which is negative 1. So this is no different than the ones that we were doing previously. It just is in function notation instead of regular notation. So now we're going to plug in 2. So I'm going to say that f of 2 is equal to, oops, I have an extra 2 there. Okay. F of 2 is equal to 1/5 multiplied by, I'm going to simplify this and I get f of 1. So 1/5 multiplied by, we just found f of 1 is negative 1. So multiply that by 1/5 and I get negative 1/5. Oops, I'm following the pattern before I put the numbers in. There we go. So f of 3 is going to be 1/5 of 3 minus 1. So f of 3 minus 1. So 1/5 multiplied by f of 2. So 1/5 multiplied by f of 2 is negative 1/5. So we'll have negative 1/25. So just looking at the differences over here, it looks like we're not adding each time, we're actually multiplying each of these by 1/5. So you could probably find the rest of the patterns from that. Or the rest of the terms, I should say. All right, the very last, oh no, just kidding, it's not the very last one. So this is similar to number 6. I wanted to go to number 9. So number 9 gives us f of 1 and f of 2. So we already have the first 2. We only have to find 4 more. So I'm on f of 3. So I'm going to plug in 3 every place that I see an n. And I'm going to simplify that. So f of 3 is the same thing as f of 2 minus f of 1. So then I go and I look, well, f of 2 is 8, f of 1 is 3. So f of 3 must be equal to 5. So my ordered pairs so far would be 1, 3, 2, 8, 3, 5. Let's do another one. F of 4 equals f of 4 minus 1 and 4 minus 2. So we will get f of, this is going to be 3, take away f of, this is going to be 2. So I go and I find f of 3, which is 5, and then f of 2, which is 8. So I get negative 3. And then you go ahead and find the last 2 values of the terms. And then part of your assignment today is going to be just like this, except you won't care about you won't care about all the extra information I gave you. You just really need to find the pattern. All this extra information is for the second part of your assignment. And then just so you don't do too much, I tried to make it big, but in your assignment on your worksheet, it says 4 terms instead of 6. I was just trying to make it a little bit less work for you. But the biggest thing that you should get out of this is understanding how we are getting these points so that you can do it backwards.